Now here we have a nice example on the geometric series which you might like to try. Just pause the video, come back when ready, and I'll run through the work solution. You could check your solutions against my workings. Okay, welcome back if you had a go. Okay, so first of all then, for part B of this question, we're told that the third and fifth terms of a geometric series are 5.4 and 1.944 respectively, and all the terms in the series are positive. And for this series we've got to find the common ratio, the first term, and the sum to infinity. Now for part B, remember the terms in a geometric series are like this. The first term is A. The next term we multiply by what is called the common ratio, r, so we'd get AR. Next term would be AR times another r, AR squared, and it would go on like this, AR cubed and AR to the power 4 and so on. So we're told that the third term is 5.4. This is this one here, AR squared, that's 5.4. And we're told that the fifth term is 1.944. That's this term here. So that's 1.944. So we've got one term there, another term there, second term, then the third, then the fourth, and then the fifth term. So in order to find the common ratio here, we know that the fifth term is 1.944, so I'm going to write that therefore AR to the power 4 equals 1.944, and the third term, AR squared, is equal to 5.4. Now normally I wouldn't write all of this up here, I'd just go straight into this, but I'm just doing it just to show you what's actually happening. And we've got two equations in two unknowns, so we can solve them simultaneously. And the best way that you can do these is to do division. Do equation 1 divided by equation 2. So I'm going to do equation 1 divided by equation 2. What's that going to give us? Well, if we just put them down, we've got AR to the power 4 divided by AR squared equals 1.944 divided by 5.4. And we can see that the reason for doing this is that the two A's cancel one another out, so it eliminates the A's. And R squared will go directly into R to the power 4. It will give us R squared. And so if we just come down here, if we work out what 1.944 divided by 5.4 is, it turns out to be 0.36. So we've got R squared, therefore R squared equals 0.36. And to get R would be equal to the square root of 0.36. Now normally it would be plus or minus. In fact, I'm just going to write plus or minus there. That would lead us to R equals 0.6 or minus 0.6. But this is the reason why they said the terms in the series are positive. So we need to take the positive value for R. So we just say therefore R equals 0.6, okay, as R has got to be greater than 0. Let's just put since R must be greater than 0. Okay, so that's part B. I've drawn it out a bit just to illustrate various points. I'm sure you could shorten it down a bit more than what I've done. Okay, we've got part C next. Find the first term. The first term, remember, is A, so all we've got to do is substitute our value R equals 0.6 into either equation 1 or 2. Up to you. I'm going to go for equation 2. So I'm going to say sub R equals 0.6 into equation 2. And if we do that, we get, therefore, a times r squared 0.6 all squared equals 5.4. So to get a is going to equal 5.4 then divided by 0.6 squared. And if you work that out, it comes out nicely that that first term a equals 15. Now in part D, again we'll just come down here, in part D we're asked to find the sum to infinity. Now we should know that the sum to infinity is always equal to the first term a over 1 minus the common ratio. And if that's the case, then all we need to do is substitute our values in. A is 15, and that's divided by 1 minus r being 0.6. So you got 15 divided by effectively 0.4, work that out and you get 37.5. Okay, so I hope you're able to follow that, and if you're still having problems with geometric series, just want some more revision, just go back to my website ExamSolutions.net, and as I say, you'll find plenty of tutorials on that. Okay, there we go. That brings us now to the end of this question.